Effect of self-repairing mechanism in concrete using biometric materials. Abstract. Cracks are easily formed in concrete. Due to the high tensile stresses, the cracks may be formed on the concrete surface. As wider the cracks endangers the strength and durability of concrete structures, so that the cost of maintenance to repair may be required. In order to enhance strength and durability, cracks should be filled with bonding and inert materials. By repair and maintenance of concrete structure, a high economic condition occurs. In this study, the biomatic materials are used to induce CaCO3. Biomatic materials used was Bacillus subtilis bacteria. Chemically induced calcite precipitate will help in the healing the premature cracks formed in the concrete structures. By providing self-healing agents, 50% of maintenance cost is reduced. This study mainly focuses on to enhance the ability of self-repairing mechanism of the concrete by the help of formation of calcite precipitation. It is also an attempt to reduce the burden of frequent maintenance and manual repair works, thus resulting in increase of lifetime of the concrete structures. Since the crack formation is major threat for the concrete structures, this study will help to overcome those catastrophic situations. Hence, by using this innovative technique of cracking healing in the concrete structures, the strength and durability will be increased compared to the conventional concrete. Keywords: biomatic materials, Bacillus subtilis, calcium carbonate, CaCO3, self-repairing mechanism. 1. Introduction. Concrete is a material which is the most widely used in construction of the buildings in the world. Natural processes such as weathering, faults, land subsidence, earthquakes, and human activities are the main reasons for creating cracks in concrete structures. The common problem found in buildings is crack. Crack may be due to many reasons. Some reasons are expansion and shrinkage of concrete due to temperature change in the environment, settlement of structure, due to heavy load applied, due to loss of water from concrete surface when shrinkage occurs, insufficient vibration at the time of laying the concrete, improper cover, high water-cement ratio to make the concrete workable, due to corrosion of reinforcement steel, many mixtures with rapid setting. Cracks makes the concrete to look unpleasant because it forms an open pathway to the reinforcement and can lead to durability problems like corrosion of the steel bars. These cracks should be repaired because they can reduce the service lifetime of the structure. In case of historical monuments, cracks makes the structure to appear spoiled. Remediation of existing cracks has been subject of research for many years. The products such as structural epoxy, resins, epoxy mortar, and other synthetic mixtures are used as filling material for cracks in concrete, but they are not environmentally friendly, not even safe for human health. Here are some 4 possible mechanisms given for self-healing of concrete, which are as follows: formation of material like calcite, blocking of the path by sedimentation of particles, continued hydration of cement particles, swelling of the surrounding cement matrix. 1.1. Self-healing concrete. Self-healing concrete consists of a conventional mix with bacteria incorporated into the concrete and calcium lactate to provide food to support those bacteria when they become active. The bacteria which is feeding on the provided food source heals the damage done and also reduces the amount of damage sustained by the concrete structure in place. Special type of bacteria is known as IJERT. 9 is 090001 www.ijert.org. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by International Journal of Engineering Research and Technology, IJERT, www.ijert.org. ISSN, 2278-0181 Volume 9 Issue 09, September 2020. Bacillus subtilis from Bacillus family are used along with calcium nutrient known as calcium lactate. While preparation of this concrete, these products are added in the wet concrete when the mixing is done. This bacteria's lifetime is about for around 200 years. When the cracks appear in the concrete, the water seeps in the cracks. The spores of the bacteria starts to grow, germinate, and starts feeding on the calcium lactate consuming oxygen. Insoluble limestone is converted from the soluble calcium lactate. The insoluble limestone starts to harden, thus filling the crack, automatically without any external requirements. When concrete structures are made with bacterial concrete, when the crack occurs in the structure, the bacteria germinate and eat down the calcium lactate which is formed by the broken clay pellets of the structure and produce limestone, which hardens and thus sealing the cracks.